Hey guys, what's going on? It's Mr. Hanson at Mr. Hanson 414. Today is Monday, October 12th. It's Indigenous Peoples Day. Happy Indigenous Peoples Day. Make sure that you guys definitely stay alert, stay woke, learn about the native people, and realize that the land that we're living on was native land, and there's a lot of things that have happened with that. That's just a little tidbit today. So go learn about Indigenous Peoples Day. It's not the other day. Stop calling it that. So today I am here to bring you guys some basic introductions to solving equations. I've got a little bit of a presentation to go through, and I've got some clips from some recordings from class to drop in. So the goal of today is for you just to kind of understand this concept of what an equation is, what it might look like, and get you ready to start solving them. But we're not solving yet. So let's get started. Actually, before I get any further, because I forgot last time, I need to give a shout out to the OG Hansonator, and that is McKenna Lee Hatfield. And I want to shout out everyone that's supporting the channel, getting me subscribers, sharing me out there to the world. Let's keep it going, keep it making, let's make everybody better at math and learn a little something, because you guys know that I know a little something about something. So let's get going. Let's get started. So I'm going to hang out. Oh, find your x. But why though? I mean, you guys know I talk about it a little bit, not as much as if we were in person, but your guys' relationship messy. And in math class, we have to find your x a lot. So hopefully you don't get triggered. Sorry. So finding out what an equation is, it's really this idea of figuring out what this unknown thing is, what the value of it is. So it's like a riddle, or trying to get that variable's number. What's your numbered variable? Let me get it. So we got to figure it out. So the number, we don't know what it is, right? We don't know something in math class. I'd say, I think you said it, a variable. Variables can be anything. That we had is 4x plus 3. It's going to be equal to 19. In about 5 years, you guys will be 19. That's the question I asked you in class today. What you going to do in about 5 years? So what number can be multiplied by 4, added by 3 to equal 19? So this looks like an equation. You might have the skills already to do that, but let's say you didn't. What times 4 plus 3 equals 19? Well, it can't be 5, right? 5 times 4 is 20. That's already too high. Could it be 4? 4 times 4 is 16. 16 plus 3 equals 19. So my number is actually 4. Riddle me this, riddle me that. That's one way to think about equations. Let's keep it rolling. I know a lot of you guys play 2K with your level 70 overall player. Maybe find a new hobby, guys. So here's just, we'll do one of these, and then I'll let you guys mess with the other one. I'll do the bottom one. My number, the unknown, has been multiplied by -5 and added by 1. My number is equal to 11. So I got to put a variable, right? Because it's an unknown. So an x multiplied by -5 plus 1 is equal to 11. So what can I put in here to make this left-hand side equal the right-hand side? Well, because this is a negative, I got to be careful. If I want to say put a 2 in it, that'd get me a -10 plus 1. That's not 11. So I'm looking at it, I got to make this a positive number. So I'd try to put -2. 5 times 2 is 10, so that's a negative. Or sorry, that'd be a positive, because a negative times a negative. Add 1. So my number in this case is -2. -2 times -5 is 10, plus 1 is 11. So the riddle method. So here's some vocab that you should definitely know. We have variables. It's just a letter or symbol that represents something we don't know yet, an unknown variable, unknown value. The solution is what we're trying to figure out, what makes the equation true. An equation, left side, right side, equal sign. It's a math statement with two expressions equal to each other. And this idea of balancing the equation. Now, let's talk about balancing the equation. A lot of times you'll see a scale, or you'll see that visual. So let's get into that. X's and ones, we're looking at bags and blocks. The question is, can we keep it balanced? And how many blocks are in each bag? Unless you have some type of crazy X-ray vision, you don't know. We have to figure that out, and that's what algebra lets us do. So let's start this. And looking at this example, and again, I'm gonna pause actually right now. I'm gonna let you guys draw this, write this down, because what I want to see is 3 bags and a block, and 2 bags, and what's that, 7 blocks? Can I draw now? I can draw now. So what you can do, if you're trying to tie the two together, you could almost think of this as like your X's. And again, some of you might have 3 X's already. Hopefully you didn't gain any new Corona X's. I don't feel like Corona would be conducive to the dating world. You guys might actually have to talk to each other. All right. You're getting this down because, again, we're trying to make that visual connection. We're thinking of the bags as the X. It's an unknown. When you don't know something, it's a variable. Every equation that we're trying to solve has something that we don't know until we do. So we don't know how many blocks each bag has. We don't know what X is worth, but we do know that the left-hand side has 3 blocks. Sorry, 3 bags and 1 block. The right-hand side has 2 bags and 7 blocks. So my question to you, through adding or subtracting bags and blocks, how can I find out how many blocks are in just 1 bag? Any ideas?
Can you like reword that again?
So looking at this, my goal is to get the 1 bag all by itself. So I know how many blocks are in that bag, how much it's equal to. So by adding or subtracting bags and blocks, how can I get a bag by itself? Like, let's look at the left-hand side. How could I get this so there's only 1 bag there instead of 3?
I don't even know. Let me think about it.
Do that. You start taking some focus supplements.
Like?
I don't know. Ask your brother, man. He's got the shop.
Okay.
You need some Ginkgo. Some Ginkgo biloba.
I think
if y'all come up there, I'll give you a discount.
Let's do it. Okay. You guys are really making me work on my own today. I might as well just be recording a YouTube video. But Melka came through in the clutch, and she says take away 2 bags. So let's do that. Now, if I take away 2 bags on the left-hand side, 1, and 2, we notice that this is no longer balanced. Yeah, if you hear like loud noises, my daughter I think has recess right now. I need to rebalance this though. I got to try and keep it balanced each time I change it. So if I took 2 bags away from the left, what could I do on the right to keep it balanced? I'm going to pause you on the block, Melka, because I want to make sure we just take care of the bags first. I got a short-term memory loss. Yes, I do.
Remove a bag from the other side.
Take the 2 bags from the other side, because if you do it on the left, you got to do it to the right. Now that'd be like me like doing my eyebrows on one side and not doing the other side. I'd look crazy. Some of you look crazy when you do both of them, but hey, that's your business. So I took away 2 bags.
And it's the same.
And it's the same, but I'm not done yet because I think Melka wants to tell me what to do. I don't have the bag by itself. I have the bag and a block. I want just 1 bag. So how can I get that 1 bag by itself on the left?
Take the block off.
Take the block off. knock your block off. And I got to do it on both sides. Thanks, Josiah. And done. So now we know that each bag is worth 6 blocks. So that would be x equals 6. That's the same representation of this because we're considering the bags are x's. How are we feeling? Again, this is conceptual. Am I going to ask you to draw a picture of a scale with a bag every time? Not at all. But could you? Yes, you absolutely could. And this is just another way to help your brain see it, because I know in math, a lot of your teachers probably taught you equations just writing it out, all the numbers, all the symbols, all the lines. Your brain kind of just mushes that all together. Now you can be like, oh, equations, think of a scale. So you're going to write that down. Equation, scale, Hansen. So when you're 17 years old, trying to remember how to do equations, you can think back to Mr. Hansen with the scale, keeping things balanced, and my eyebrows being fleeky. That'd be like Morano shaving one side of his head. Can't have that. Can't have that.
I mean, it's there, but you could. But get that mohawk down the middle for charity, I would.
How about everybody gets a 4 one day? All right, here we go. I want to do a new problem, but I don't know if it's going to let me. Oh, that's why I'm clicking on the marker. All right. Let's do one more together. Maybe 2 more. This problem looks a little different. We got 2 bags on the left, 1 bag on the right. Goal is still to figure out what each bag is worth, how many blocks are in that bag. It looks like I got 7 blocks on the left and I got 10 blocks on the right. Now you might be able to logically in your head be like, oh, I think the each bag has 6 blocks, 5 blocks, 4 blocks, whatever. But can somebody help me out, walk me through this? And again, if you're drawing this on, if you're doing this on paper, if you're doing this yourself, what you could draw is you could draw a little scale. You could draw a little bag. I'd put an X in it. You could draw your little blocks. And then when I delete them, because you obviously don't have a delete button on your pen, you just X them out. That's my pro tip of the day. So somebody tell me, anybody, what can I do to figure out what each bag is worth? How many blocks are in each bag?
Nah.
Yeah, shoot that shot, Denham. You can't keep pump faking. Shoot the shot. You might be wrong. You might miss it, but you will take that shot. I'll get the rebound.
Hey, sometimes you gotta pump faking, like, you know?
Yeah, but if you keep pump faking, you turn the ball over.
No, I'm I get them jumping.
Someone has a question on page 2 of the gym board.
Oh, goodness. What? First of all, that's not really a question, and I'm not getting into this debate right now, but I can tell you, if I'm picking up one player in a game, in a series, in a year, in a career, I'm taking MJ all day. If you put MJ in the league now, dude was scoring like 30 points a game when he was like 43.
Yeah, he's scoring 50 today, if he was in his prime.
And MJ is like the GOAT, like manipulator. He would be in your head. It'd be over. Like LeBron's a great player, but he's not MJ. I'm going to take away a bag from the other side, says Milka. So I'm going to do that. Great. But does one bag equal 10 blocks? No, because it's a bag and looks like I got 7. So what do I got to do now to get the bag by itself? I mean, the Lakers winning, it is what it is. Miami didn't have a strong squad. They got injured.
Oh, wow. But
I mean,
if they would have won, they would have.
Okay, guys, back to math, guys.
How many blocks?
How many blocks? I mean, Bam was hurt. He never was the same. Dragic was hurt. Barely played. Dragic's their leading scorer, dude. Take away 7 blocks. And I'm going to take away 7 on the right. Vanessa's on it. And then there we go. We know that one bag equals 3 blocks. 1 3-pointer is worth 3 points. Okay. Let me get a 1 to 4 in the chat. Let me know how you're feeling. at those other videos, another example, bagging up some candy. Halloween, our neighborhood's doing it, so I think what we're gonna do is just put out bags ahead of time and a little something so people can just grab and go, safe, cleanly. Stop. So in this case, 9 Sour Patch Kids, 2 bags of Sour Patch Kids is equal to 3 bags of Sour Patch Kids plus 4. Well, if you recall, whichever you do one side, you do the other. You got to keep it balanced. Shout out J. Cole. Get rid of a bag, get rid of a bag, get rid of a bag. Got rid of 2 bags on both sides. Got to get rid of these 4 Sour Patch. Get rid of these 4 Sour Patch. 1 bag equals 5. B equals 5. And this is where I got it from. So credit your stuff. So that's there. It's another example of this whole balancing idea. And now this is a little pre-work because we're not quite there yet. I'm not going to start talking about algebraically solving till the next time. But we have all our properties, the addition property of equality, subtraction, multiplication, division. What you do to one side, you do to the other. So it's using the inverse operation to undo. So if you're adding, you're subtracting. If you're multiplying, you're dividing. If you're dividing, you're multiplying. If you're subtracting, you're adding. Whatever you see is happening in the equation, you do the other on both sides. That's the key. Do it to both sides. Yeah, we're just going to cut that out. So let's get back to this. All right, guys, it's spooky season. We're out here. I might have to add more stuff to my wall, but we're starting this idea of what equations are. And I want you to think about it as 2 sides, a left side equal to a right side. Whatever's on one side is equal to the other. If I add something to one side, I got to do it to the other. If I bring some French fries home to one of my kids, I got to bring it to all my kids. Otherwise, there's going to be a problem. If I do my eyebrows on my one side, I got to do my eyebrows to the other side. I'm going to look a hot mess. If I fade up one side of my hair, I got to do the other side of the hair. Keep things balanced. If you put that foundation on, that little green stuff to cancel out your redness, you got to do it on both sides or you're going to look a hot mess. So, equations, we're going to talk about solving them. We're going to get into the more algebraic way. But for now, this concept of a scale, this concept of the hanger, finding the unknown value, that's what I want you to trigger in your brain as your memories. And again, happy Indigenous Peoples Day. Learn your history. I'll see you guys later. Hit that subscribe button. Mr. Hanson 414.